Okay, hello again, classes. All right, ayan. So the next part of our discussion would be the different methods of paraffin impregnation. Okay, so for those who are under me in the laboratory, I have discussed this as part of your post-laboratory or as part of our post-laboratory discussion. Okay, but since I have LCD section, na hindi collab, hindi collab ang LCD. Tama naman, hindi ko kayo lab, di ba? Okay. Hindi ko lab ang LCD. Ang lab ko lang ay LCA at saka LCC. Okay? So that's why I have to discuss it also in the lecture for my non-lab, for my non-lab section, which is LCD. Okay? So yun po. All right. So, after discussing the characteristics, the advantages, and disadvantages of paraffin wax, so let us now proceed to the different methods of paraffin impregnation. Okay, so just like what I have mentioned, yeah, sige na, wag ko nang i-mention. Okay. So, for the different methods of paraffin impregnation, this was actually part of your QFR, right? Of your QFR in the laboratory. So, we have three methods. We have your manual method, we have your automatic method, and of course, we have your vacuum embedding. Actually, ang nakalagay talaga doon sa Gregorius ay vacuum embedding. But please do not be confused, because even if it says there vacuum embedding, what it performs really is impregnation. Okay, you start with impregnation. Okay, with the use of your vacuum embedding method. All right, so sorry. First, we have your manual. Okay, manual method of paraffin impregnation. So for our manual method, okay, so we have to look at the required temperature again. Okay, so the required temperature for manual paraffin impregnation is 2 to 5 degrees Celsius higher than the melting point of the wax. Okay, but again, just like what I have previously discussed, you have to be careful not to exceed the temperature beyond 60 degrees Celsius. Otherwise, it will already be deleterious to your tissue sample. Remember, the immersion is not short, diba? Just like the schedule of activities that is indicated in your module for experiment or for activity 2A, how long are you going to immerse your tissue sample in your paraffin? It's 1 hour. 1 hour to 1 hour to 30 minutes, diba? 1 hour and 30 minutes, okay? So that's a very long time for it to be immersed in high temperatures. So that's why we have to be careful not to exceed the 60 degrees Celsius mark. Okay? So yon. So we follow the same procedure pa rin po when it comes to the required temperature. Okay? So for your manual tissue processing, okay, number of changes is 4 changes, and the interval or the duration is 15 minutes. So this is what was mentioned in your Gregorios. Okay? But actually, if you are reading other references, it's not, yes, the other references would say that it would require longer immersion. Okay, longer immersion. Like some references would indicate 30 minutes. Okay, some references would indicate 1 hour, 1 hour and 30 minutes, so on and so forth. Okay, yan. So for the duration, actually, the duration of immersion in your melted paraffin, it is dependent upon the thickness of your tissue sample. Okay, this is dependent upon the thickness of your tissue sample. Okay, yan. So that's why for the lecture, ang i-follow na lang natin ay what is indicated in your Gregorios. Okay, which is 4 changes at 15 minutes interval or at 15-minute interval. Okay, so for the embedding, for your manual procedure, it requires 3 hours embedding. Why? This is to ensure that the entire block has solidified already. Okay? Yeah. So, if you do not solidify the entire block, okay, the tendency is the tissue sample that is supposed to be properly oriented will no longer be properly oriented. Okay, so this is to ensure that the block has completely solidified so that the proper orientation of your tissue sample is maintained. Okay, yes, another, we have your automatic paraffin impregnation. So for automatic paraffin impregnation, the required temperature is at least 3 degrees higher than the melting point of the wax. Okay, so at least 3 degrees higher than the melting point of the wax. Okay, oh, I forgot to mention pala. So the equipment that we use for your manual, okay, for your manual tissue processing, so we either make use of your general oven, so the oven, yeah, general or common oven, general oven na lang. Okay? General oven that is also utilized in other sections of the laboratory, or we can also make use of your paraffin oven if it is available in the laboratory. Okay? So for our automatic paraffin impregnation, we make use of our tissue processors. Okay? So automated tissue processors. Ayan. So that's the equipment that we use. Okay? All right, so again, for automatic, the required temperature is at least 3 degrees Celsius higher than the melting point of your wax. Okay, and how many changes? How many changes? We have 3 changes. And the good thing about your automatic processing is that the impregnation or infiltration process is accomplished in the presence of agitation. Okay, in the presence of agitation. Okay, and this agitation or the presence of agitation is an important factor that will differentiate the quality, okay, the quality of processed tissue when you perform manual paraffin impregnation as compared to automatic. Okay, so what is the effect of agitation in paraffin impregnation? Agitation class, okay, or classes. So this will accelerate, okay, this will accelerate, okay, and improve penetration. Okay, syempre kung gumagalaw-galaw yung solution mo doon, okay, so if your solution or if your tissue sample is agitated, this will also facilitate the movement. Ay, ang tsaka. Okay. So this will also facilitate the movement. Okay. The faster movement of your molecules, thereby allowing and accelerating, improving and accelerating the penetration of your paraffin wax. Okay. Saglit lang class. Ilagay ko lang dito. Accelerates and improves. Okay, improves penetration. Yan. So it will accelerate and improve the penetration of your wax. Okay, so since the penetration of your wax is improved in the presence of agitation, so this will lead to, ayan, so this will, okay, dito na lang sa taas class ha. Okay, yan. So this will eventually lead to more consistent results, okay, as compared to your manual tissue processing. Yan. So this will lead to more consistent results. Okay, so just like what I have mentioned previously, so if you are going to compare your manual and your automatic processing, of course, in manual kasi, there is subjectivity as for the performance of the procedure because it will differ from one personnel to another. Yan. This is something that really exists in the laboratory. Okay? So although what we want is dapat mawala yung subjectivity, right? However, it would still be there. I mean, it's unavoidable. Especially if we perform manual procedures. There will always be a factor of subjectivity to it. Okay? So like for example, some personnel would have better skills as compared to others. Okay, that's one. Another is, of course, like for example, if the personnel is so tired during that day, okay, yan. And apart from that, you cannot really agitate your sample or your solution in the manual procedure. Diba? Katulad nga ng sabi ko, alangan namang ipasok mo yung kamay mo dun sa oven. Okay? And then i-stir mo yung paraffin wax or i-move mo yung iyong sample. You cannot do that. Okay? So that's why if you compare the consistency of results, your automatic paraffin impregnation provides more consistent results because the subjectivity of the procedure is already removed because it's automatic. It's the tissue processor which will perform your paraffin impregnation in the presence of agitation. Okay? So another thing that you have to consider for automatic would of course be, just like what I have mentioned, mention. Okay. Ayan. So just like what I have mentioned, okay, so the duration of your processing, this actually depends upon the thickness of your sample. Okay, just like when it comes to the duration in your manual. Okay, so thickness, I got this from Gregorios. Okay, so if your sample is 3 millimeters thick, okay, the duration for automatic processing, so we have 2 to 3 hours. Okay, 2 to 3 hours per change. Okay, so I repeat, if the thickness of your sample is 3 to 5 millimeters, so it would require, okay, it would require 2 to 3 hours per change. Okay, so 2 to 3 hours per change. Okay, another is, yan. Okay, another is, this one naman I got from another reference. So if, for example, your tissue sample is 2 millimeters thick, okay, so if it is 2 millimeters thick, okay, so we immerse it in the first paraffin for 10 minutes and then followed by 20 minutes. Okay, 20 minutes immersion in another fresh paraffin. Okay, so these values I got from Anpries. Ayan. So yung unang value 3 to 5 millimeters thick, 2 to 3 hours per change, I got that from Gregorios. Okay, so 2 millimeters thick, and then the other one given was for tissue samples which are 4 millimeters in thickness. Okay, so if you make use of 2 changes of alcohol, the first change is 20 minutes. And then the second change is 40 minutes. Okay, so yan. So these values I got from Anpries. Okay, so 2 millimeters thickness, 10 minutes for the first paraffin, 20 minutes for the second paraffin. 4 millimeters thick, we have 20 minutes in the first paraffin and then 40 minutes in the second paraffin. Okay, ayan. So those are the recommended duration for automatic processing. Okay, considering the thickness of your tissue sample. All right, yes. Okay, so now let us move on to, tanggalin ko lang po. Okay, let us move on to the last method. We have your vacuum method. Okay, so yan, vacuum method, the required temperature is 2 to 4 degrees Celsius higher than the melting point of the wax, okay? And infiltration is done using 3 changes of melted paraffin, and it should be at a negative pressure. That is the reason why we refer to it as your vacuum method. So negative pressure, in layman's term, this is actually referred to as your vacuum. Okay? So the negative pressure that is required to be present inside your vacuum machine, okay, or your vacuum processor is 400 to 500 millimeter mercury. Ayan. So 400 to 500 millimeter mercury. Okay? The good thing about the presence of the negative pressure inside your equipment or inside your machine is that it will allow or it will facilitate easier removal of your clearing agent Apart from that, it is also able to remove air bubbles which may be present inside your tissue sample. Okay? So, class, parang sa ano ito, this is comparable to the vacuum that is present in your evacuated tubes. Okay? Remember when we perform phlebotomy, okay, you don't really have to do anything once the needle is already pricked. Okay, once your two-way needle is already pricked and it's inside your evacuated tube, and then the other needle is inside your vein, so blood will automatically flow into your evacuated tube. This is because of the presence of vacuum inside your evacuated tube. Okay, so hihigupin niya. It will aspirate or suck. It will suck the blood automatically into the evacuated tube. So it's the same principle that is involved in your vacuum impregnation or infiltration. Okay, remember the first thing that you have to do, or yes, the first thing that should take place in impregnation or infiltration is that you have to remove first your clearing agent. Okay? So the faster you remove your clearing agent, the faster your paraffin wax will be able to penetrate your tissue sample. Okay, so yan. So that's why, since you are able to remove your clearing agent faster in the presence of a negative pressure or vacuum, so your vacuum method is considered to be the most rapid because it allows faster penetration by your paraffin wax. Faster removal of your clearing, faster penetration of your paraffin wax, thus it is considered to be the most rapid. Okay? So the time for impregnation or infiltration is significantly reduced. Okay? So you can reduce it, ayan, you can reduce it by 25 to 75%. Yan. So it is reduced to 25 to 75%. Okay? So that means as compared to your automatic and your manual, your vacuum, okay, your vacuum, the duration of your infiltration in your vacuum method is shorter by 25 to 75%. Okay? Yan. So is this advantageous? Yes, of course. Because I have emphasized already the consequences of exposing your tissue sample to heat. Okay? To heat, right? There is really a consequence, sabi ko nga. There is really a consequence. We cannot avoid it. Okay? So the exposure of your tissue sample to heat, there are consequences. Specifically, your tissue sample will really become hard and shrunken. Okay, which is just like what I have mentioned, worsened if it is exposed to heat for prolonged periods of time. But that one is avoided in the case of your vacuum method. Kasi nga shorter yung duration. So that means if the duration is shorter, then its exposure to heat becomes shorter also. So your tissue is not overexposed to heat. And so the different consequences may be avoided. Okay? The different consequences may be avoided, or if there are consequences, it's only minimal. Okay? The effects will be minimal only in your vacuum embedding. So such that shrinkage, brittleness, and hardness is avoided. Over or excessive brittleness, excessive shrinkage, excessive hardness of your tissue sample is avoided. Okay, so that's the good thing about your vacuum method. No overexposure to heat, or the exposure to your heat is minimized. That's why the effects of heat will also be minimized. Okay? Ayan. So, in the laboratory, what are the applications of your vacuum method? So, it is utilized, number one, for urgent biopsies. Okay? Since it is the most rapid, so if you are going to process an urgent biopsy or an urgent sample, then the best method of paraffin impregnation is your vacuum. Okay, so another, it's also utilized for dense and fibrous tissues. Okay, so since it is utilized for, since your dense and fibrous tissues, they are considered to be hard tissues. So I mentioned it in the video on clearing. If it's not clearing, it's dehydration. I just forgot from in which video I mentioned it. Okay, remember I said that dense and fibrous tissues, they are considered to be inherently hard tissues. Okay, so since they are inherently hard, and hardness is associated as a consequence of the different steps in tissue processing, you don't want to make it even harder during infiltration. Okay, kasi in fixation, is there hardness? Yes, because you need to protect your tissue sample. Diba? That's one of the purposes of fixation, to make your tissues hard. Okay? Adequately hard so that it will be protected from the damaging effects of the succeeding, steps in tissue processing. In dehydration, is there hardness? Yes. Because that is a consequence of, hindi ako galit I'm not mad, okay? Because that is the consequence of performing dehydration. Okay? That is the consequence of immersing your sample in your dehydrating agents. Another, in clearing, is there hardness? Yes. Okay? Again, that's a consequence of making use of your clearing agents, particularly if you are performing a routine procedure. In routine procedure, what do we use? Saline. What is one of the effects of your saline? Hardness in your tissue sample. Okay? So there's hardness, 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 hardness. Alangan namang sa paraffin impregnation, there is hardness pa. Okay? So in order to not make your tissue sample even harder, kasi tumigas na siya sa fixation, tumigas na siya sa dehydration, tumigas na lalo siya sa clearing. Alangan naman, okay? Alangan namang katip sa impregnation, papatigasin pa natin siya. Alright? So as much as possible, we don't want it to be harder than it already is. Okay? So that's why, yes, for inherently hard tissue samples, the recommended method is your vacuum. Okay? Because we don't want to make it even harder. Okay, ayan. Another, and then the last application, we have your delicate tissues. Okay, so what are delicate tissues mentioned by, okay, what are delicate tissues mentioned by Gregorius during infiltration? Okay, so ano yung mga delicate tissues natin? So delicate tissues would include your lungs, your eyes, and your spleen. Okay? So these are considered to be delicate tissues which are supposed to be processed using your vacuum method. Okay? Yan. So delicate, they are delicate in the sense that they are more susceptible, they are more vulnerable, okay, to the effects of heat. Yan, particularly your lungs. Remember that your lung sample, it can be, it can contain air bubbles inside. Okay, and what is one of the purposes, or one of the purposes of your negative pressure, to remove your clearing agent and to remove your air bubbles. Right? So if you are handling lung samples, the best method for paraffin impregnation is of course your vacuum. So this will allow the removal of not just your clearing agent, but also your air bubbles. Okay? If air bubbles are present in your tissue, of course, it will not be infiltrated. That space in your tissue that is occupied by your air bubbles will not be infiltrated by your paraffin. Okay, why? Because air is not soluble in paraffin. If it's not soluble, if one is not soluble with the reagent, it will not be replaced. Okay, they have to be soluble. All right, so yan po. So those are Okay, the things that you have to remember for the different methods of paraffin impregnation. Oh, I forgot. Okay. As for the duration of vacuum, okay, your vacuum method, so how many changes again do you need? We have three changes, okay? So melted, empty na lang ha, melted paraffin 1, okay? So you have to immerse your sample in melted paraffin 1 for 15 minutes, okay? Melted paraffin 2, so you have to immerse it for 30 minutes. And then melted paraffin 3, you have to immerse it for 45 minutes. Okay, so that is, or those are the intervals or duration of immersion for your vacuum method. So 3 changes for 15 minutes, 30 minutes, and then lastly, we have 45 minutes. Okay, yan. So apart from the methods of impregnation, it is also important that we consider the paraffin wax itself. Okay, so what are the different considerations for your paraffin wax? So the most important thing that you have to know is that your paraffin wax has to be pure. Okay, so when we say pure, what do we mean? So when we say pure, what do we mean? We mean, or we want your paraffin wax to be free from contaminants. Okay? So it should be free from contaminants. So what are examples of contaminants which may be present? So we have your small particles. Yan, small particles. What else? Granules which may be present. Okay, what else? Debris, other debris which may be present in your wax. Okay? The problem with the presence of your small particles, your granules, and your debris in your paraffin wax is that they will be incorporated inside your tissue sample. Okay? And of course, if they get incorporated inside your tissue sample, they will become part, okay, of the section that you will produce later on. And the problem is, okay, the problem with that is these contaminants they will tend to obscure, okay, anatomic details na lang. Okay, so they will tend to obscure the details, anatomic details, which should be observed by the pathologist. So in English, papatungan niya. That's the meaning of obscure. Papatungan niya or itatago niya. Okay? The important anatomical details which is supposed to be examined by the pathologist. So if the details are obscured and the pathologist will not make or will not be able to see the details, this will now interfere with the results or with the diagnosis, okay, of the patient by the pathologist. All right, so that's why you have to ensure that your paraffin wax is pure. Okay, so in order to do this, if you are using your fresh wax, okay, you have to filter it at 2 degrees Celsius above the melting point, okay, prior to use. Yan. So again, part of your QFR, di ba, how many times are you going to or can you use your wax? You can use it twice. So that means reused wax, such as those that come from trimmings. Ito, reused na ito. This is not fresh already. So wax from trimmings, okay? So you have to filter it with a coarse filter paper. So an example of a coarse filter paper that was mentioned by Gregorius, we have Greens, okay, Greens number 904. Okay? Yan. So this is an example of a coarse filter paper that we use for the filtration of your wax, your reused wax. Okay? Yan. Another contaminant which may be present in your paraffin is or are your water molecules. Okay? So this serves as another contaminant. Yan. Why is it a contaminant? Because take note that water is not soluble in your paraffin. Okay? So that's why you have to remove it. Otherwise, it will also be incorporated in your tissue sample. Ayan. So, how do you remove water molecules? You let it evaporate. Okay? And when it comes to the evaporation of your water, of course, you have to heat it at its boiling point in order for it to be removed. Thus, okay, the removal of your water molecules from your paraffin wax, this is carried out at 100 to 105 degrees Celsius. Okay? So this is carried out at 100 to 105 degrees Celsius. Alright, so those are the different considerations. Okay? Yes. So after performing paraffin impregnation or infiltration, the next thing that you have to perform is your paraffin embedding. Okay. So in paraffin embedding, yes, I will be showing a video for this. Okay. Yes, I will be showing. Ano lang, wait lang. Ano? Ay, yes. Okay, maghanap pa ako ng kandila. Or kung walang kandila, siguro crayons na ano. Crayons na i-melt ko na lang, ganun na lang. Okay, anyway. So, paraffin embedding, ayan. So, after infiltration, the next thing that you have to do is to embed your tissue sample. And the required temperature of the melted paraffin for embedding is it has to be 5 to 10 degrees Celsius above the melting point of the wax. So, that means you have to heat it or you have to maintain it at a higher temperature for embedding. Okay? Why? This is because at lower temperatures of your melted paraffin, it tends to have bubbles. Nagbabubble po siya. Okay? So in order to avoid having bubbles in your block, okay? In order to avoid having bubbles in your block, the required temperature for your melted paraffin is higher. It's 5 to 10 degrees Celsius above the melting point of the wax. Okay? Ma'am, bakit higher? Di ba, ma'am, we don't want it to be exposed to greater than 60? Yes, correct ka. Yeah! Sorry. Yes, may tama ka. Okay, tama po. Yes. But remember, infiltration takes a longer time as compared to embedding. Pag nag-embed ka naman, class, hindi na siya inside the paraffin oven. Hindi na siya inside the oven. Okay, you don't maintain it at a particular temperature for a period of time. Yung melted paraffin wax lang talaga siya. Yung embedding, we perform it at normal temperatures, at room temperature. Whatever is the temperature in your laboratory. Okay? So, saglit lang siya. Diba? Saglit lang siyang mainit, in short. Okay? So, kunwari, ito yung ating mold. Okay? Nandun yung tissue sample mo. So, the temperature of your melted paraffin is, again, 5 to 10 degrees Celsius higher than the melting point of your wax, right? So, ipo-pour mo siya doon sa ating mold, okay? And then after some time, it will cool down. Okay? So, that means you are not really exposing it for a long period of time, not even 5 minutes or not even 3 minutes. Because one of the characteristics of your paraffin is that it easily cools down. Okay? It easily cools down. It easily cools down. All right? So do not be bothered by the higher temperature. Kasi unlike in your paraffin, you have to maintain it at that temperature for 15 minutes. Oh, is that a long time? Yeah, it's a long time. It's a long time coming. Okay? Yes. So, pag pour mo ng paraffin, magkukul naman yun eh. Diba? It will cool down. So, don't worry. Don't worry. Okay? Yes. All right. So, after you have already poured, okay, your paraffin wax into your mold, so allow it to cool. Okay, so for faster cooling, you can refrigerate it at -5 degrees Celsius. You can even immerse it in cold water, okay, or you can cool it using your tissue tech. Your tissue tech, this is an example of a mold. And the good thing about your tissue tech is that it has a cold plate already at the bottom. So that will now allow faster cooling of your paraffin wax. Okay? Yes. Ayan. So, in the laboratory and in certain instances, your paraffin wax might not be available. Okay? So, there are there is a group of waxes which we refer to as your paraffin wax substitutes. Okay, so they are referred to as your paraffin wax substitutes because you still follow the same procedure. So that means from fixation up to clearing, it's still the same. So the only thing that is different would be you will not be making use of your paraffin wax during infiltration and embedding. What you will be using are the substitutes. Okay, so what are these different substitutes for your paraffin? So first, we have your paraplast. Okay, so from the term itself, para, it contains paraffin. Plast here indicates the presence of your resin or your plastic. Okay, by the way, in histopath, okay, plastic is otherwise referred to as your resin. Ayan. So kung ayaw mong maging obvious masyado, I have a resin friend. Oh, ganon. May plastic akong kaibigan. Ganon. Para hindi ka masyadong halata. Nag-uusap kayo sa labas. Ay, si ganito, napaka-plastic niya. O, di ba? Alam naman na ng lahat kung anong ibig sabihin ng plastic. So, para hindi masyadong halata, ay, napaka-resin nitong si ano. Oh, ganon. Okay? So, in histopa, ganun talaga yung tinuturo ko sa inyo. Okay, para indicates the presence of your paraffin. Okay, and of course, the word plus there, okay, the word past indicates the presence of your plastic or resin. Okay, so the word plus there indicates the presence of your plastic or your resin. Okay, so the good thing about it containing a plastic or a resin is that your paraplast, it is more elastic and resilient. Okay, it is more elastic and resilient as compared to your paraffin wax. Okay. And since it is more elastic and resilient due to the presence of your plastic, okay, it provides better ribboning. Ayan. So it provides better ribboning. Okay. No cooling is required because in addition to the paraffin, your plastic will automatically undergo polymerization. Ayan. So that's why it does not require cooling. It does not crumble because it's elastic. Okay? So in histopath, we want plastic. Okay? Sa histopath, gusto natin ng plastic. Love natin ang plastic sa histopath. Because we are able to provide better sections. Okay? We are able to cut easily if there is plastic in your medium. Okay, ayan. So another paraffin wax substitute, we have your embedol. Okay, so your embedol, it has a melting point of 56 to 58 degrees Celsius. And it is considered to be a synthetic wax. Okay, it is considered to be a synthetic wax. So as compared to your paraplast, your embedol is less brittle. Okay, it is less brittle as compared to your paraplast. Another paraffin wax substitute, ito favorite nila do sa board exam. We have your bioloid. Bioloid, this is a semi-synthetic wax that is oftentimes utilized for the infiltration of your eye samples. Okay, for the infiltration of your eye samples. And then lastly, we have your tissue mat. Okay, so the mat there, the term mat there indicates the presence of your rubber. Okay, so this is a product of paraffin that contains rubber. So the elasticity or the resilience that is associated with your tissue mat, this is because of your rubber. So in paraplast, the resilience and elasticity of the medium is due to the presence of your plastic. So in tissue mat, it's because of the presence of your rubber. Okay? Yes. So other paraffin wax substitutes. Okay, so the remaining paraffin wax substitutes, they do not follow the process of paraffin. Okay, so the processing of your tissue would require an entirely different procedure. Okay, so we have your ester wax. Okay, your ester wax, it has a lower melting point as compared to your paraffin. So specifically, it has a melting point of 46 to 48 degrees Celsius. However, di ba, our general rule is that the higher the melting point, the harder the wax. But an exception to the rule is your ester wax. Because although it has a lower melting point, which is at 46 to 48 degrees Celsius, your ester wax is harder than paraffin. Okay, so it is harder than paraffin. Okay, and important characteristics that you have to know when it comes to your ester wax. It is already soluble in your 95% ethanol, and it is also soluble in your clearing agents. Okay? Ayan. Yeah, ring a bell. Ring a bell. Chung, 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 chung. Okay, yes. Kasi, balikan natin we go back to the purpose of dehydration and clearing. What are they? Okay. Remember, they are preparatory steps for your infiltration. So that means we perform dehydration, we perform clearing, so that your tissue sample becomes compatible with your paraffin. Tama? With the medium that you are going to use in your infiltration and embedding, right? But take note, your ester wax, it is already soluble in 95% ethanol. Okay? So that means from dehydration, you can already, immerse your tissue sample next in your ester wax. No need to perform clearing. Kasi remember, what is the purpose of your clearing? The purpose of your clearing is to remove your dehydrants. Okay? It is to remove your alcohol particularly. Why? Because alcohol is not compatible with paraffin. Okay? Yan. That's why you make use of clearing or you perform clearing. But since your ester wax is already soluble in 95% ethanol, it is already compatible with your 95% ethanol. Okay? So that means you perform fixation. Okay? So after fixation, you perform dehydration. Okay? After dehydration, you can already proceed to ester wax. Ayan. So, pwede na agad na ester wax. You can omit or you can skip the process of clearing already. Okay? Yes, that's the significance of that. So, you can omit the process of clearing. Okay, yan. Kasi compatible na siya. Yun lang naman yung ano natin dito, class. Our concern is really just the compatibility of your tissue sample to the next reagent that you are going to use. So after dehydration, is your tissue sample compatible with your ester wax? Yes. Okay, so you don't have to perform clearing. Nakuha? So you can already start with your ester wax. Okay, you can already move on to your infiltration. Okay? However, if, for example, sige, sinisipag ka, you still want to perform clearing. Okay, so ester wax processing with clearing. Okay, so the required reagents that you are going to use is, okay, so you can make use of your Cellusolve. Ayan, so you can either make use of your Cellusolve or Silene. Okay, so these are the reagents that you should use prior to the next step. Okay, so first step, immerse your tissue sample in Cellusolve or your Silene. Okay, so after that, you immerse your tissue sample in equal parts of clearing agent, kung alin ang ginamit mo, either your Cellusolve or your Silene. Equal parts of clearing agents plus your ester wax. Okay, plus your ester wax. So you immerse it in equal parts of your clearing agent plus your ester wax for how long? We have 3 to 6 hours. Okay? So after that, you can already make use or you can already immerse your sample in pure ester wax. Okay? So how long are you going to immerse it in pure ester wax, or how many changes rather? So we make use of 3 to 4 changes of your pure ester wax. Okay? So after 3 to 4 changes of your pure ester wax, yes, so the next one, you are already done with your infiltration and then you proceed to embedding. Okay, so you proceed to ester wax embedding. Okay, so after embedding, of course, the next step is sectioning, right? Yes. May I just mention it also? Since your ester wax is harder than your paraffin, ano dapat? What is the required type of microtome that you need to use during sectioning? So you need to make use of your heavy duty. Okay, you need to make use of your heavy duty microtome. Okay, microtomes or microtome. Since your ester wax is hard, it is a hard medium. Okay, that we can use in or that we use in histopath. So examples of heavy duty microtomes that we have in the laboratory, we have your sliding microtomes. Okay, we have your sliding microtomes. All right, so that is your ester wax processing. Okay, so now let us move on to your water-soluble water-soluble waxes. So actually, your water-soluble waxes, they are also classified under your paraffin wax. But again, just like for your ester wax, it requires another type of processing. Okay? It requires another type of processing. Okay? Ayan. Not the same as that of your routine paraffin processing. Okay? So water-soluble waxes, they are oftentimes polyethylene glycols with a melting point range of 38 to 42 degrees Celsius or 46 to 56 degrees Celsius. Okay, so I repeat, these are polyethylene glycols with melting point ranges of about 38 to 42 degrees Celsius or 45 to 56 degrees Celsius. So the most commonly used water-soluble wax in the laboratory is your Carb Wax. Okay. What is one thing that you have to remember for your water-soluble wax? Ano yung pinaka-importanting karakteristik na dapat ay alam ninyo? Nandoon na po sa kanyang pangalan. Okay? Ano ang pangalan niya? Water-soluble wax. Okay? The significance of this is that, remember, ulit, balikan na naman natin. Why do you have to perform dehydration and clearing? You have to perform dehydration and clearing in preparation for your infiltration. We would want to make our tissue sample compatible with the medium. That's why we remove water. We remove alcohol or whatever dehydrating agent you used. Right? In order to make your tissue sample compatible with whatever medium that you're going to use later on. However, your Carb Wax is already water-soluble. Okay? Is it compatible with water? Yes, definitely. Will it be able to replace water? Yes, definitely, because they are compatible. Okay? So that means you can omit the dehydration process. No need to remove water. Okay? You can omit clearing because you did not perform dehydration na nga. Right? Okay. So that's why if you're going to look at your Carb Wax processing, after your fixation procedure, you perform washing out. Okay? To remove excess fixative or to remove precipitates or pigments which may have been formed during the fixation process. And then after that, Carb Wax. Okay? After that, Carb Wax na agad. Yes, because you don't have to remove the water because it's already, your medium, your Carbo Wax is already compatible with water. It can remove the water. Okay? It can. It can replace the water because they're compatible with each other. Okay? So there are two steps that you can omit. You can omit dehydration. You can omit clearing. Alright? And this will lead to a reduced processing time. Apart from that, the harmful effects which are brought about by the use of your dehydrating agents and clearing agents are avoided. Okay? Yes. All right. So how do we perform your Carbo Wax processing? Dito ka na lang class ilagay ha. Okay. Last na itong Carbo Wax and then gawa na lang ulit ako ng isa pang daming video, no? Oo, gusto ko ibigay ko na lahat para tapos na. Okay? I'm not naman, hindi ko naman sinabing you watch all videos today. Okay? Because, just like what I've mentioned in the first video, your quiz for this one will be on Thursday pa naman. Okay? On Thursday pa po. Kaya, okay lang, wag tayong ma-stress. Okay? You have until Thursday po. Wag pa lang Thursday, you have until Wednesday to watch all of the videos. I think it's gonna be three videos, okay? Yes, you have until Wednesday to watch the video. Okay, because your quiz is on Thursday. So entire, lahat. Alright? So yan. How do we perform your Carbo Wax processing in particular? Okay, so Carbo Wax processing is performed with constant agitation. All with constant agitation at 56 degrees Celsius. So this is, this is when it comes to your INF na lang. Okay, so this is when it comes to infiltration. Okay, Carbo Wax infiltration, it should be performed with constant agitation at 56 degrees Celsius. Okay, so we make use of several concentrations of Carbo Wax. So first, we make use of 70% Carbo Wax. Okay, so how long are you going to immerse it in 70% Carbo Wax? We have 30 minutes. Okay, and then after your 70% Carbo Wax, we follow it by using 90% Carbo Wax. And how long? We have 45 minutes. Okay, and then followed by 2 changes of 100% Carbo Wax. How long? We have 1 hour. Okay, so I mentioned 2 changes. So another, that means you make use of another 100% Carbo Wax for another 1 hour. Okay, so after your infiltration, the next thing that you have to perform is embedding. So you make use of fresh Carbo Wax, and the temperature should be at 50 degrees Celsius. Okay, and then after embedding, you have to rapidly cool it in ref. Right, so yan. So infiltration, we have infiltration with constant agitation at 56 degrees Celsius, 70% for 30 minutes, in 90% for 45 minutes, in 100% for 1 hour, in another 100% for 1 hour, and then embedding is carried out using fresh Carbo Wax at 50 degrees Celsius. And then your Carbo Wax block is rapidly cooled at ref temperature. Okay, at ref temperature. All right, ayan. So as you can see, there are a lot of good things or advantages of your water-soluble waxes. Okay, so its application in the laboratory, yan. So you can use it for histochemical and enzyme studies because the chemical constituents and your enzymes, they are not destroyed. Okay, they are not destroyed because you did not perform dehydration and clearing, which are particularly destructive to your chemicals. Okay, so apart from that, you are able to demonstrate your neutral fats and your lipids. Remember, what is your neutral fats again? That's your triglycerides or triacylglycerides, which is the storage form of lipids in humans. Okay, so those are the applications of your Carb Wax in the laboratory. Okay. It being water soluble, tanggalin ko na ba? Hindi. Okay, it being water soluble also has some disadvantages. Okay, so since your Carb Wax is considered to be water soluble, it is highly hygroscopic. Okay, so it is highly hygroscopic. So meaning it has an affinity to your water. Okay, it has an affinity to your water and it is dissolved by water. Kasi soluble nga siya eh. Okay, so it is dissolved by water. And so, okay, and so you should avoid contact, okay, with water molecules or even ice. So due to its hygroscopic nature, you have to avoid contact of your block with water or ice. Okay? The problem here is when you perform flotation. Why? Because remember that in the flotation technique, you have to make use of your water bath, right? So that's basically the purpose of your water bath. Or that's basically what is being used rather in your water bath. Water. Okay, in order to flatten, straighten your sections and remove wrinkles from your sections. Okay, so in order to facilitate the flotation, yan. So in order to facilitate the flotation of your Carb Wax sections, there are two remedies that we can perform. Okay, number one, you can add, okay, you can add soap or add soap or 10%, okay, PEG. Ano ibig sabihin ng PEG? We have polyethylene glycol. Polyethylene glycol 900. Okay, so I repeat, you can add soap or 10% polyethylene glycol where? To your water bath. Okay, so that means you still use water, but you have to add soap or 10% polyethylene glycol to your water bath. Okay, so that's one remedy. Another remedy is, of course, you can make use of your floating solutions. Okay, you can make use of your floating solutions. So that means you don't use water in your water bath. Instead of water, you make use of the floating solutions. Okay? So there are two floating solutions that we can use. We have your Pierce solution, and then the other one is your Blanc, okay, and McCarthy. Alright. Isa lang yan ha. So please do not, wag ninyong ihiwalay. Do not separate Blanc and then McCarthy. Okay? Because they refer to one solution only. Alright, so yan. So those are the remedies in order for us to float your Carb Wax sections. Okay, syempre if you just make use of water only, what will happen to your sections? Your sections will be dissolved. Okay, so that's the problem. Yan. So you can still make use of the water bath, but you have to add soap or 10% polyethylene glycol 900, or instead of your water bath, you make use of your floating solutions. So we have two floating solutions. We have your Pierce, and then the other one is your Blanc and McCarthy. Okay, so that ends this video on our discussion regarding paraffin wax, okay, as well as the different substitutes of paraffin. So I will be preparing another video to discuss the other media that we use in the laboratory. Okay, so again, I'll see you. Yes, bye. Stay safe, everyone.